So what we're going to look at is how to convert a log when we're given certain information and we're given these logs. So we want to use that information. So we're going to take our log number, which is 15. We want to change it into either 3 or 5 or both. So we can put or substitute these numbers in. And we're going to use the properties. And the first property is multiplication, which simply means I'm going to separate the logs by using addition. So let's first rewrite log 15 base 4 as a multiplication problem, and I'm going to use 3 and 5, and the reason is because 3 and 5 are given to us up top in this given information up here. Now I can separate my multiplication problem log 4 or log 3 base 4, and I can do an addition. This is the product property of logarithms. It gives me the log of 3 base 4 and the log of 5 base 4 as an addition. And now I can substitute in 0.7925 because that's what that equals because it's given to us. And the log of 5 base 4 is 1.1610. And if I add those two up, I get 1.9535. And so I've just approximated this log by separating it using the product property by separating it into addition. So let's look at another example real quick. If I have log 27.4, I want to separate that with numbers given. Well, I don't have a 5 in that, but I do have a 3. So if I write this as log of 3 times 3 times 3, that would give me 27. And now since I have multiplication, I can separate the logs into additions of each of those logs. So log 3 base 4, which is given to us up here again. I want to reiterate that. So it's 0.7925 plus 0.7925 plus 0.7925. And if I take 0.7925 and add them all up, I will get 2.3775. And so sometimes you can repeat the numbers and sometimes you can just use the ones that are given to us, but you have to find numbers that multiply to give you these base numbers, or not base numbers, but the logs, so we can use the property of product property. So just like we did the product one, we also have a quotient one. That means when you have a division or a fraction, we can rewrite this, and we want to rewrite it with either one of these two bases. So we want it where 5 and 3. Well, this one might be a pretty simple one. So I'm going to separate this as a log 4 or base 4 with the 5. And because it's a division, I can do the subtraction. So I'm going to subtract at the bottom log base 4 with the 3. And so if you looked at, I have these two. I just took this fraction and separated it into a subtraction sign and rewrote it. Now I can do each of these separately. Log base 4, 5, which over here is 1.1610. I'm going to minus. The log base 4, 3 is 0.7925. And so once I substitute the numbers what they approximately equal, I can then subtract them. x10 minus 0.7925, and I get 0.3685. And that's an approximate, so I do a squiggly line, and there's my answer. So what we're trying to do is figure out how to solve these type of problems, because you can't do a calculator, and you can do it by separating if they have give you information. And we want to create the problem so it looks like these, so we can do the math. Okay, this last type problem is the power property. The power property simply means if you have an exponent, so if you look at the property up here, see 6 to the 5th power, that 5 can actually be written as a time sign in front of the log. So if we have our answer here, we want to find out the log of 2/25th, we can rewrite that as 5 to the 2nd power. And the reason I'm doing the 5 is because we want to make it look like this. Well, this part looks like that, but we have this exponent. Well, the power property means that exponent becomes in front, so times. So I rewrite it as this. So all I did was take the exponent that was here, that was here and moved it in front. That's what the power property means. So once I have it in front, now I can change this to what it equals, and it equals this. So I'm going to put that in parentheses, 2.3219. That's this part, and I still have my 2 in front, which means I'm multiplying. So now you can take your calculator and go 2 times 2.3219, and you get approximately, and I'm doing a squiggly line, 4.6438. So another way of figuring out a log is change this number right here to a exponent of that number. And so I changed it to the 5, and that's how I created an exponent that I could put in front to do my multiplication.